We always come across stunning images of distant galaxies on the internet. Galaxies that exist around us, millions of light years away. Despite the challenges, we can capture clear images of them, thanks to telescopes capable of observing vast distances. Until now, the universe has been beautiful, and there haven't been any issues. However, the problem arises when we try to capture an image of the Milky Way, the galaxy that we are actually a part of. How can we photograph it from within? Hello everyone, I'm Bassem Nasser. But before we start, if you're new to the channel, don't forget to subscribe and hit the bell icon to receive our videos promptly. Imagine standing in a stadium with a mobile camera that has a zoom function, and you're asked to capture a clear picture of the entire stadium. The challenge is that the image should cover the entire stadium from start to finish. What would you do? The simple answer is that you would leave the stadium, move to a considerable distance, and then capture the image. This is the method we used when capturing large objects. But can we apply the same principle if we want to capture our own galaxy, just the Milky Way itself? Let's explore the most advanced tools that humans have sent to the farthest reaches of space, and see if these distances are enough for us to photograph the galaxy from the outside or not. In 1977, NASA launched the Voyager 1 spacecraft, which explored Jupiter and Saturn, sending us images and information about them. It continued its journey beyond the Kuiper Belt, exiting the boundaries of the solar system completely, and it will keep moving in space until its nuclear battery runs out in 2036. Here we ask the question, after all these years, how far has it managed to reach? After 45 years, it has covered approximately 23 billion kilometers. While this number may seem daunting at first, is this distance sufficient for us to photograph the Milky Way from the outside? Let's consider the width of the Milky Way, estimated to be at least 100,000 light-years, to compare this figure with the distance covered in kilometers. We need to unify the units of measurement, converting light-years into kilometers. 1 light-year is roughly equal to 9.5 trillion kilometers. For the galaxy, like that? People claiming to show galaxy images, is it a scam, right? In reality, no. The preceding information means that we cannot photograph our galaxy using traditional methods, such as distancing ourselves and taking a photo from afar. If we were to ask someone if we had done that, it would indeed be a scam. However, this doesn't mean there aren't other ways to capture the galaxy while being inside it, as we previously discussed with the stadium example. What do you think? If we approached someone inside the stadium, took their mobile phone with a camera, and respected their capabilities. We told them, "We want you to capture the stadium this time, but we won't make it difficult. Stay inside. You can take photos from your regular spot, but use a slicing method. Stand in one place and start capturing each section of the stadium around you separately. A photo of the stage, a photo of the right stands, a photo of the left stands, a photo of the second screen. Capture each section around you while standing in your place. Afterward, take all these photos and assemble them together, like we do in a puzzle game. Then you'll find that you have a panoramic image of the surroundings. It's like someone captured it from the outside, but not with the same precision." This is exactly what astronomers did when they captured it. This whole thing isn't something recent. It's not an invention or anything. Many scientists throughout the ages were the ones who initiated this method of thinking. Modern space agencies followed in their footsteps and continued their work due to technological advancements and equipment availability. In ancient civilizations, people observed something strange appearing in the sky during specific months and then disappearing. It was a long, massive ziggurat dividing the sky in half, containing large clusters of colors. Back then, they didn't fully understand it, right? Exactly. And even today, we could observe such a thing if we were in the desert or in an extremely dark place like Wadi el-Hitan in Fayum, for instance, without telescopes. People used to record these observations and also document the locations of stars. One of the most famous ancient records illustrating star maps and their positions is the masterwork of the astronomer Claudius Ptolemy, who lived in Egypt throughout his life, specifically in Alexandria. Despite Ptolemy's inaccuracies, his model served as a useful foundation. Significantly, his maps remained a reference for astronomers for hundreds of years. We have traversed a long period, until the year 829 AD, when the Shamasia Observatory was established in Baghdad during the Umayyad Caliphate era. It is considered the first astronomical observatory in Islamic civilization. Muslim scientists began to modify Greek astronomical books and add to them, such as Abu al-Rayhan al-Biruni, Muhammad ibn Musa al-Khwarizmi, Ibn Sina, and others. During this period, Muslims discovered a tremendous amount of stars and categorized them into groups. The map of the sky became increasingly clear, and interestingly, many stars still carry their Arabic names to this day, such as Suhail, Aldhanab Aldebaran, and others. Moving forward through the years to the Renaissance era, between the 14th and 17th centuries AD, European astronomers began measuring the positions of stars in the celestial dome and recording their locations precisely, especially with the development of Galileo's telescope. The first European to attempt to draw a complete picture of the galaxy was the British-German astronomer Frederick Herschel. He divided the sky into multiple sections, capturing individual shots through the telescope from more than 600 different locations on the Earth's surface. When he compiled all this data together, by the year 1785, he arrived at the shape of our galaxy, now known as the Herschel map. This map is still recognized today. After more than 100 years of Herschel's attempts, a Dutch astronomer pressed on and conducted a similar but more advanced experiment, especially since his measurement plan included the apparent size, spectral type, and radial velocity of stars in more than 200 different locations. He collaborated with 40 observatories, and by the year 1917, an American astronomer, Harlow Shapley, after studying globular star clusters, stated that the previous studies were based on the assumption that the solar system is located at the center of the galaxy, but this is not true. Our solar system is situated at the outskirts of the galaxy, and that's why. These maps needed adjustments, and around the same period, approximately in the year 1920 AD, one of the most renowned astronomers ever, the American scientist Edwin Hubble, began studying space using his telescope. He provided crucial results, indicating that the universe around us is full of many galaxies. However, these galaxies are, for some reason, confined to three main shapes. The first shape is spherical or elliptical, where the galaxy is like a massive ball with stars distributed in it in a semi-regular and homogeneous arrangement. The second type is the spiral galaxies, and these galaxies consist of a central part called the galactic bulge, giving it the name the galactic heart. The shape can be either spherical or elliptical. Most of the galaxy's mass is concentrated in this central region, with a very large number of stars clustered around it. Near the galactic heart, there are spiral arms winding around it, and the size and number of these arms vary from one galaxy to another. Spiral galaxies are the most common type found within them. The third type represents irregular galaxies, and these are considered the least observed galaxies to date. Here, astronomers noticed something important. The strange tendrils seen in the desert were very similar to the arms extending from the center of spiral galaxies. If our galaxy were spherical or elliptical, we wouldn't see this massive cluster of stars in a distinct line. This observation further supported the hypothesis. In 2003, the Spitzer Space Observatory was launched, which is an observatory that collects infrared radiation and measures its wavelengths. Through its observations, we confirmed that the center of our galaxy consists of a cluster of red stars, giving rise to branches that form the arms of the galaxy. However, it was uncertain whether there were 4 or 2 arms. Through the extensive explorer known as WISE, Wide Field Infrared Survey Explorer, launched by NASA in 2009, we were able to determine that the center of the galaxy has prominent arms, which are the Sagittarius arm and the Scutum Centaurus arm, along with 3 smaller arms, the outer arm, the Perseus arm, and the local arm, the latter being where our solar system is located. Through the accumulation of data collected over hundreds of years, we ultimately concluded that this is the shape of the Milky Way, resembling a barred spiral, but not necessarily with 100% accuracy. All right, folks, give us a like before you leave so we can see how many have reached the end.